Okay, we're going to go ahead and start with 1.3 literal equations. First thing you need to know, what is a literal equation? Well, literal equations are scientific equations, mathematical. So all these examples you see here, perimeter, circumference, areas, distance, temperature, all of these are examples of literal equations. And what we're going to do today, we're going to rewrite. We're going to rewrite them and solve for another letter. So if we have, say, circumference equals 2 pi r, I can solve for circumference because this is the formula it's set up for. So we can solve for circumference c. I can solve for c if I know what r is, because pi is going to equal to 3.14. So that's one way to solve for circumference. But let's say I wanted to solve for radius. Okay, then this formula has to be changed, and there's ways to do this. So let's start with something easier. Let's start with an example. Let's start with area of a rectangle. So area of a rectangle is equal to length times width. So we're going to, as a first example, let's rewrite, and we're going to solve for L. So we want to know what L is. Well, we have the original formula. The original formula is area equals to length times width. So I want to know what L is. And what we're going to do is we're going to treat every letter like if it was a number, which means we're still going to do the inverse operations like we did in the previous sections. So A is, think of it as a number, think of W as a number, and we have L times W. So if we're going to use inverse, we're going to use inverse operations for this. Length times width, and we want to, and again, think of yourself as the L. So if I want to be left alone and I'm being multiplied by my friend here who's next to me, that means it's a multiplication. We want to do the inverse of that. So we're going to go ahead and divide. So we're going to divide both sides by W. So we'll divide this side by W. The A, where the area is, we'll divide by W. Remember, if you do something on one side of the equation, you must do the other. Property of equality. So the W's cancel. And we have L equal to A divided by W. So I'm just going to rewrite this as L equals to area divided by W. So we rewrote this and solved for the value of L. So L equals to area divided by the width. Now let's look at another example. Let's say I choose this formula right here. Area of a triangle, which is A equals to 1/2 base times height. So I'll write it right here. Area equals to 1/2 base times height. And I want to solve, let's say for this example, we're going to go ahead and rewrite and solve for h. Okay, so if I want to solve for h, I need to get rid of the half times the b times the h, or if you know what, let's make it easier. Let's change this. 1/2 b times h is really base times height divided by 2. So let's do it that way. Let's do area equals to base times height divided by 2. I want to solve for h, so to solve for h, I want to get rid of this 2. So let's multiply both sides by 2. So I'll go ahead and multiply this side by 2 and multiply this side by 2. Why did I decide to multiply by 2? Well, because I want to do the inverse of a division. And I can't solve for h until I first get rid of 2. I can't, because b is kind of, I can't get rid of b until I get rid of 2. So I'm going to do the inverse operation of dividing by 2, which is to multiply. That way the 2's cancel. And now I have 2 times a is going to equal to b times h. Okay, and again, we want to solve for h. So you're still by you want to be left alone. Here you are. You got rid of your friend of 2, and now you have your friend here of b, and you need to get rid of your best friend who's being multiplied, so b times h, and since it's being multiplied, we need to do the inverse of that. Well, the inverse of multiplication is division, so we're going to go ahead and divide both sides by b. And b cancels. And so our final equation here is going to be h equals 2 times A, or 2 times the area, divided by the base. Okay, so now I can use this formula to solve for the value of h, which is the height. Unlike the first formula, which was 1/2 base times height, I couldn't do that. Well, you could, but it'll be messy. If I rewrite the problem, rewrite the equation, then it makes it a lot easier for me to solve for height. So let's say I am given an area of 10 feet squared, and I'm given a base of 5 feet. And they said, well, what's the height? Okay, so a easy way to do this is to use your rewritten equation of h equals 2a divided by b, and I can solve for h. So if I plug this in, I'm going to get height, and let me write it here on the side. So height is going to equal to the area, which is 10 feet squared, times 2, because it's 2 times h, times a, all divided by b, the value of 5. Well, this is nothing more than 20 over 5, and this would equal to 4 feet. So that means that my height would be 4 feet. So this is what we're going to be doing here for the rest of the lesson. We're going to learn to rewrite and solve for a different variable. Always treat your variables like numbers. Always do the inverse operations, so nothing's changed. Okay, let's move on to. Okay, so let's look at this example right here. You are ordering pizzas and sandwiches. You have a budget of $80. How many sandwiches can you buy if you buy 4 pizzas, 5 pizzas? Explain your answer. Okay, so pizzas are $10 and sandwiches are $5. You can see that from the menu. I'm going to go ahead and give you the formula. Right now, I don't want to focus on the formula itself. So the formula is going to be, well, it's $10 for pizza, so it'd be 10 times P. And the sandwiches are $5, so it'd be 5 times S to represent sandwiches. And our budget is no more than 80, so that should equal no more than $80, so we'll be equal to 80. So this is the formula we're going to use. I'm not focused so much on you guys right now thinking of the formulas. Let's rewrite this. So we want to know how many sandwiches. Because we don't know how many sandwiches, we need to know how to solve for this. We need to know how to solve for S. So we want S to be by itself. So again, we're going to rewrite and solve for S. Okay, and if we do that, then we're able to use the information of 4 pizzas and 5 pizzas, plug it in, and find out how many sandwiches we can purchase. So I'm going to take 10p plus 5s. That's going to equal to 80. And again, since we're solving for S, that means that our S value is you're trying to be by yourself. So we're trying to solve for S, you want this to be by itself, so you want to move everything else to the other side. So the first thing we're going to do is we're going to go ahead and subtract the 10p. Okay, so we subtract the 10p, and I'm going to go ahead and put it minus 10p. I'm going to put it on the side here. I'm not going to put it underneath because I can't subtract 80 minus 10. So just to avoid confusion and not to make a mistake, I'm just going to go ahead and write it as 80 minus 10p, because that's what's going to eventually happen. We got to separate them. So the positive 10p cancels the 10p, and then I have 5 times s, and that's going to equal to 80 minus 10p. Now the reason I can't subtract these two numbers, the 80 and the 10, is because you're talking about apples and oranges. One is just numbers, okay, it's just a constant 80, and the other one, well, it has a variable. It has value of p, so I can't. If I had other p's, then I could add those and combine those terms. But because I can't do that, I'm going to leave it like that. Alright, so now the next thing is to get rid of our friend here, 5. It's the one right next to us. And again, anything in front of a letter, anything next to each other, that's implied that it's being multiplied. So we're going to go ahead and do the inverse of multiplication, because this is 5 times s. We're going to divide. Okay, 5's cancel. And so our equation is going to be already here on the side. S, our sandwiches are going to be based on 80 minus 10p, all divided by 5. So if I know p, the number of pizzas, then I can find the number of sandwiches I can purchase. See how rewriting now makes more sense. So by rewriting this, it makes everything a lot easier and a lot easier to solve. So let's go ahead and start with the first part of the problem. They asked how many how many can you buy if you buy 4 pizzas? How many sandwiches can you afford? So here's our formula. We're going to use the S equals 80 minus 10. So I'm going to just write down S is going to equal to 80 minus 10 times the value of P. Well, we are doing for P for pizzas. All right here. P is going to be 4 pizzas. So we're going to plug in 4 for P. So there's our formula, 10 minus 10 times P, all divided by the value of 5. So now let's simplify this. This is nothing more than S equals to 80 minus 40, because 10 times 4 is 40, divided by 5. And so this is going to be 40 over 5, which is 8. Therefore, we could only purchase 8 sandwiches. Okay? Alright, let's do another one. Next one said, well, what is it for 5 pizzas? So now we're going to go ahead and do this for 5 pizzas. So we're going to say P is 5 pizzas. Okay, we're going to use the same formula. S equals 80 minus 10 times 5 divided by 5, and we're going to end up with, I'm going to kind of go a little bit faster. This is 80 minus 50, which is really 30 over 5, and that's going to equal to 6. So S, the number of sandwiches we could purchase, are going to be 6 sandwiches. Okay, so that gives you an idea how rewriting helps you solve problems. And so you're gonna have to be able to do this on the STAR exam, where you're gonna have to rewrite equations. So let's go on to the next example. Okay, so we're gonna go ahead and rewrite a literal equation with only variables. So what equation do we get when you solve a times x minus b times x equal to c for x? So what they're asking us to do is they want us to know what is going to be the value for x. So we need to rewrite this and have x by itself and solve for x. So let's go ahead and we're going to go through this a little bit faster. I'm just going to go ahead and show you kind of the step-by-step procedures. Alright, so the first thing you want to do is you want to write the original equation. So we write it down as a times x minus b times x. Now, if we want to solve for x, we have a that has an x, and then you have b that have an x. So both of these have x, and what you're going to do is you're going to factor out the value of x. And if you don't remember what factoring out looks like, let me go ahead and show you. And we're going to go ahead and use the distributive property. X is common between both, so that means that x gets factored out, and that's what you're seeing right here. The x gets pulled out from the a and the b, gets pulled out, and then so you're left with this parentheses to represent the multiplication, which is the distributive property, because you can always go back and check it. X times a is ax. X times b is really bx. So all I've done is took out the x because they both have x in common. So I take it out, put a parentheses around what's left over, in, which is the a minus the b. So we're going to go ahead now that we've taking out the value of the x, now we can solve this by dividing. So we're going to divide each side by a minus b. Remember, this is in the parentheses, and I want to know what x is, so I'm going to get rid of this by dividing both sides by a minus b. So on the right side of the equation where you have c by itself, it's going to be c divided by a minus b. So what's going to happen now is that the ab and this ab are going to cancel. So look at the steps that we did. We have x in common. We can factor out the x using the distributive property, and x is outside now. And we're left with the parentheses of a minus b, and that means we can divide both sides by a minus b, and we do it also on, if we do it on the left side, we must do it on the right side. Again, property of equality. So our final step is, our final answer is to simplify. So we have x equals to c divided by a minus b. So what equation did we get? Here it is. C over a minus b for solving for x. Okay, so that gives you an idea how to solve these and what the expectations are to solve these problems for this STAR exam. Let's go on to the next example. Okay, we're going to look now at geometric formula. So we're going to look at what is the radius of a circle with a circumference of 64 feet, round to the nearest tenth, and use 3.14 for pi. So pi is going to be 3.14. So we're going to need the formula. So let's go back to the formulas that we had from the beginning of this video. Circumference of a circle is going to be 2 pi r, and r is going to be the radius. So let's go ahead and go back now. So c equals 2 pi r, and we're going to rewrite and solve for r. Okay, where r is going to be our radius. So first thing is to rewrite this formula. So we're going to have c equals to 2 pi r, and I want to solve for r. So what I need to do is get rid of the 2 and the pi, because 2 and pi are next to the r, so they're both being multiplied. So what I can do is just divide both sides by the 2 and the pi. That way these cancel. Alright, now if I divide by 2 pi, then I must divide the left side of the equation where the c variable is, and divide that by 2 pi. Okay, so I'm left with r equal to circumference divided by 2 pi. Now, when I rewrite this formula, let me use a little darker pen here. I'm going to go ahead and write that our new formula is going to be r, then, therefore, is going to equal to circumference divided by 2 times the value of pi. And remember, pi is 3.14, which we're going to replace for that. So if we're going to solve for r, then r is going to equal to the circumference, and we have circumference. Circumference was given to us as 64. Okay, 64 feet. And we're going to use pi of 3.14. So we're going to go ahead and substitute those values in. So for c, we're going to write 64 divided by 2 times 3.14. And if we plug this in, approximately r, and if you want to know what approximately symbol is, we don't use an equal, we use a little squiggly lines. This means r is approximately equal to 64 divided by 2 divided by 3.14 is going to give us about 10.2 once we round to the nearest tenth, and so therefore our radius is 10.2 feet, and that would be our answer. Okay. All right, let's go on to the final question, and this is more of a word problem for this. Okay, our final problem is the following. The monarch butterfly is the only butterfly that migrates annually from north to south. The distance that a particular group of monarch butterflies travel is shown. So let's see what they're talking about here. So here's our picture, and if you notice, the number of distance, the miles is right here. It's going to be 1,700 miles. Okay, it takes a typical butterfly about 120 days, so we'll highlight that also, to travel one way. What is the average rate at which a butterfly travels in miles per day, round to the nearest mile per day? Okay, so we need some type of formula. So we're going to go back to our beginning of the notes and look at these scientific formulas, these little equations. And we're looking at distance, time, and rate. So that means that what we're going to use is we're going to use the distance traveled and use d equals to r times t. D is the distance, r is the rate, t is the time. So we're going to go ahead and use that formula for this problem over here. So if I write it just right now, this is distance equals to rate times time. If I were to rewrite this and solve for, what are they asking for? They're asking for the average rate. So that means that we want to solve for r. So we want to divide the t so we get r. So the t cancels, and I'm left with r equals to distance divided by time. So that's the formula we're going to use to solve this equation. So that's what you see right here. We are going to use the formula of d divided by t equals r. From there, we are going to substitute values. Well, what we're going to substitute are the 1,700 that is over here on the image, and the 120 days that we're going to use for time. So the distance was 1,700 miles, the days was 120, so we're going to substitute those values for d and t. Okay, we plug that in the calculator, and we're going to round off to the nearest mile because that's what they ask us to do. So if we round to the nearest mile, the rate r is going to be approximately, remember these little lines mean approximately 14, so that was rounded off. And to conclude, the butterflies travel at an average rate of about, again, estimated 14 miles per day. And that would be our answer. Alright, don't forget to do summary at the end of these notes. Talk about the different formulas, the rewriting, the procedures that we just talked about. If you have any questions, bring them up the next morning, and we'll see you then.